All right, hello guys. I'm sorry I couldn't be there today. Um, you've already had a chance to check your homework, and I'll just collect those. You can turn those into the sub, and I'll collect those and put those in the grade book tomorrow. I've already sent the answer key to the sub, and you've got everything you need. What I want you to start with is solve these inequalities. These are just one-step inequalities. You'll have to create your own number line. I'll give you guys about 3 minutes to do that. And then, so you can go ahead and pause the video, and when everyone's had a chance to do it, you can go ahead and check your answers against the video. All right, so now that you've had a chance to talk about this one or do these, I'll do that first one. D plus 3 is greater than or equal to 8. So we'd subtract 3 or add negative 3 from both sides. So D is greater than or equal to 5. So my number line would look something like this. I'd have a closed circle, and it would be facing the right. Okay. My next one, h divided by 6 is less than 2. I'd multiply both sides by 6. So we get h is less than 12. So my inequality, my number line would look something like this. 12 in the middle, open circle, going for less than. For number 3, g minus 3/4 is greater than 1/8. So we'd add 3/4 to both sides. But in this case, we're going to go ahead and just switch it to adding 6/8. So we say g is greater than 7/8. Here's my number line down here. So we'd say this time it's 7/8 would be my number right there, and greater than would show an open circle going to the right. The last problem is Will has $60 to spend on a bottle of juice at school. If the bottle costs $1.50, write and solve an inequality to find out how many juice bottles he could have. So your first set would be 1.5 times x. Again, we'll say let x equal juice bottles. Now again, you could put whatever letter you want on this one. Okay, and I need it to be less than $60. It can include $60, so we can have that undersigned. So we divide everything by 1.5. All right, so we come over here and go, okay, how many times is it going to? Roughly about 40 times. So x is less than or equal to 40. Okay, and if you went ahead and graphed on a number line, you're welcome to. I don't think it was required, it doesn't say to, but you'd say 40. It could include 40 and go down. Okay. All right. So now today we're going to start our first lesson in area, and we'll go over our test on block day. We've got one more person that still needs to take it, and then we'll go ahead and take the time to start working from there. All right, so today we're going to talk about how to find the area of parallelograms and triangles. So different sets of parallelograms, but we're going to talk first about give us some vocabulary. Okay, so let's think our way through this vocabulary. The first thing we've got to do is find out what is a polygon. Okay, so when we talk about a polygon, it's a shape. Now, a polygon and a shape are two different things. A shape that has with at least 3 sides, with, I forgot the words, at least 3 sides, made up of straight lines, made up of line segments. So in other words, a shape, a circle, is not a polygon. So you can have triangles, you can have parallelograms, you can have rhombuses, you can have squares, you can have pentagons, you can have octagons, but you can't have a circle. A circle is not a polygon. Okay. The next one is a parallelogram. So the parallelograms have certain rules to make them. It is a shape, it is a quadrilateral, so that means it's a 4-sided shape. Okay? And I know you guys talked about this in your previous years. A quadrilateral with 2 sets of parallel lines. And the opposite sides are adjacent. Or opposite sides are equal, not adjacent. I'm sorry. Opposite sides are equal. All right, and we have an option. It could look something like this, or it could be something like this. That's a parallelogram, or even a rectangle. So all of these are different kinds of parallelograms, squares, parallelograms, rectangles. All of those can be considered a parallelogram. Then we've got a rhombus. A rhombus is a more specific parallelogram. So it has the same rules as a parallelogram. It's a quadrilateral, okay, with two sets of parallel lines. But here's where it changes. And 4 equal sides. So a rhombus would look something like this, where all 4 sides are equal to each other, assuming I could draw perfect. This is also a rhombus. It's a square. The big difference between the square and the square has to have 90-degree angles at the corners, where a rhombus does not. A square is also a rhombus, but a rhombus cannot always be a square. Okay, and we can play with that later on in block day. Give you a few seconds to finish that. Pause this if you need to, let them catch up on their writing. All right, and let's take a look at the next couple words. So the base. Okay, so just to give us a little bit of idea, just giving us some vocabulary. It's the horizontal, okay, or left to right measure of an object. Measure of a polygon. Polygon, there we go. This helps if I can write correctly. And the height, well, if the horizontal is this is the vertical measure. Bottom to top, top to bottom, measure of a polygon. Okay? And then finally, formula. A formula is just a generic term for the way to find a certain measure. So,
okay, I found this on the web for a certain measure. Check it out.
Goodbye, Siri. Now, to want a certain measure. She must think I was talking to her. So it's a way to find area. It's the way to find volume. It's the way to find surface area. It's a way to find those certain measures. Okay? It's distinct and different for every single lesson or for every single shape, because each shape has a different way to find it. And that's what we're going to really be focusing on over the next couple months, probably about almost 6 weeks, is what are all these different measures? How are the different ways I can find area and volume and surface area of different shapes and polygons and figures? Okay? Today we're going to focus on polygons. One of the best things to do is actually to pull the original information from a problem as simple as this. We know somewhere in your life you learned that area of a rectangle is length times the width. So now, after today's lesson, we've kind of taken that and changed it out. This side was the length, NGTH. This side was the width. That can be a little confusing at times, especially when I write really poorly. So we renamed it when we get to these kinds of problems. The formula to find area of a polygon, since we've renamed this base part down here base, and this side height, this gives us a common idea. This has a base, this has a height. So the problem is, and we're going to talk about how do we get from here over to here, and what does that lead us to down here. So one of the things that we'll do as we play through this, since I'm not here today, it's kind of harder to do. But if I was to take this parallelogram and I turn it into a rectangle. Well, yeah, I could. If I took the scissors and I cut right here, and I took that shape and I moved it over here, would that make the same rectangle? Yeah, this would be the same as this rectangle. So one of the neatest things about it is the formula for this can be derived by just looking at this. It's the area equals the base times the height. Now, one of the nice, cool things from here is I can use that same formula, that same picture, to make myself figure out the area of a triangle. If I took my parallelogram and cut it in half, did I just create 2 triangles? I did. So how did I do it? I cut it in half. So the formula for a triangle is 1/2 of the base times the height. Because if I doubled this up, now I have that same parallelogram I had above. Well, if I drew a perfectly straight line, I did. That's the way I can go from starting with what you knew down here, over here, and here. We can figure out all of our formulas we need. So that's exactly what the formula is. The area of a parallelogram, how much space it takes up, is the product of the base and the height. Now the height has to be measured specifically. You'll notice the height will have to be measured at 90 degrees. You wouldn't measure your height standing on an angle leaning against a wall. You have to stand straight up, okay? So if we set up our first problem, and then we have the area of a rectangle, I don't know why this is also messed up. Area of a triangle, we said earlier, was area is 1/2 of the base times the height. Because like we said, it'd be like taking that parallelogram and cutting it in half. And again, that height is measured at 90 degrees. So let's take some time and practice this. Sometimes they show the measure outside, like this, and we have this is not the height. That's the first thing we have to get. It is not the height. The height has to be measured at 90 degrees, so it's over here. So we're going to say, and it's important that you guys use the formulas. You do the base is 20 times the height of 11. Okay, so we go 20 times 11, all right. So the area of this feature is 220. Now, the one thing about this that I want to talk about, and a lot of people don't think of, is it's really 20 centimeters times 11 centimeters. I alluded to this earlier in class. I'm not going to force you guys to write the units here, but I want to make sure we understand it. When we talk about units like this, we're treating them really as a set of variables. We're not just thinking of them as just a number. It's a variable, because variables are just things that stand for numbers, and we know a centimeter is just about this much space. So it stands for a number. So we're going to treat it like that. If I have two that I multiply together, anytime I have repeated multiplication, I actually have product. We have exponents. So this would be 220 centimeters squared. You go ahead and try this next one. Pause the video, and then I'll put the answer up, and you guys can restart it once you got it. All right, so you guys quickly put this together. Is 5 times 8, and you got 40 centimeters squared. Okay. Now, what if we look over here and go, what if I'm missing a dimension? Well, if I use my formula and I plug in my information where I know, I can figure out everything else. Okay? So if we set up this problem, we know the formula is area equals base times height. I don't have the height. So let's fill in everything I do know. 45 is the area. We don't know base, but we do know height. We don't know height. Sorry, we know base. We know the base is 9, but we don't know the height. So let's solve for it. We divide both sides by 9. Height equals 5 inches in this case. Okay? And again, we would divide inch over inch squared over inch, and that would let us have 1 inch left. All right, go ahead and try to figure this one out. Pause the video and see what you guys come up with. All right, so I know you guys plugged it in. Centimeters squared equals, we know the height, so we know the base. We don't know the base, so we know 7 centimeters times the base. If we divide both sides by 7 centimeters, we won't go into the exponent law that helps us figure this out, but easiest way to think about it, I've got centimeters times centimeters. One of them would cancel out, so you end up with 3 centimeters is the base. Okay. All right, let's move on to these next two. So if we look at the painting of this replica of the national flag of Trinidad and Tobago, for a research priority, find the area of that stripe. Well, that stripe right here, that black stripe, is a parallelogram. And we can find the height over here, and we can find the base here. So area equals 6 3/4 times 12. Oh, now we got to bust out our fun math. So it becomes 27 over 4 times 12. You'd cross reduce down to 1 and 3. 3 times 27 happens to be 81 inches squared. Inches, there we go, squared. All right, you guys figure out what is if Jose's building that dog run for his school, a parallelogram, for his dog, sorry, find the area of that space the run will enclose, and I'll give you a few moments to work it out. Pause the video and see what you come up with. so I got 6 1/4 times 10 1/2. So I went ahead and did my conversions. 25 over 4 times 21 over 2. Sadly, I can't cross reduce anything. So 21 times 25, well, 20 times 25, I happen to know is, let's see, so that's 4, there's 524 of those. I get 525 over 8. Now I've got to reduce. I've got to go and do the math. So I'm going to come over here, 525 divided by 8. I get 6, carry the 4, or drop the 4. I guess I'll show the whole math, no short division for me. 45, 8 goes into 45, 5 times. And I could keep going, but since I'm stopping here, it's going to say 65 5/8 feet squared. Here's my final answer. Now I could use decimals, but fractions are much better, and that's how the answer was given, so that's what we're going to start in. All right, let's transition to triangles for a minute. So the area of a triangle is area equals 1/2 of the base times the height. That's my formula I work with. Again, here's our height measured in from the 90 degrees. Even though it's going down, it's still the vertical measure. So area equals 1/2 times 12.1 times 6.4. Now, here's the really cool part about this. I don't have to go left to right. Since it's all now multiplication, I can use some math and think, okay, I can take half of 6.4 and say area equals 12.1 times 3.2. Makes it a little easier on my math. 12.1, 3.2. And I'm going to say 2 times 2, that's 4. And then 0, 3, 6, 3. So I'm going to do my work. I ran out of space over there. So 2, 7, 8, 3. So 38.72 meters squared. All right, go ahead and try that next one, and then I'll put the answer up. Now that you've had time to work the problem, let's go ahead and plug in our math and work this one out. So again, our formula is area equals 1/2 of the base, which in this case is 16, times the height of 8. We're going to say, and again, because this is this amazing process, I don't have to go in order. I don't have to do half of 16 or half 8. I can in this case. So half of 16 is going to be 8, so area equals 8 times 8. So my area is 64 centimeters squared. Okay, so far so good. All right, let's move on and take a look at finding the missing dimension style of triangle problems. So again, we're still using our base formula. Okay, area equals 1/2 of the base, which we don't know in this case, times the height, which is 6. So, and the last thing we can plug in, we can take out the area. We know that's 24. So the first thing you want to do is combine all like terms. So get it simplified to a one-step equation. So it'd be 24 equals half of 6. So it would be 3b. Now you can simply divide both sides by 3 and get b, our base, is 8 centimeters. Okay? So, and you could always plug it into text to test it. 1/2 of 6 times 8. 6 times 8 is 48. Half of the 48 is 24. That's the correct answer. We've got it. All right, now you figure out what the height of this triangle is. Pause the video and you can play again when you're ready to check it. All right, so let's plug this in. Area equals 1/2 base times height. So we're going to say 6 is equal to 1/2 of our base, which is 3, times the height. So 6 is equal to 1.5 times height. Divide by 1.5, and h is equal to 4 inches. All right. All right, now let's look at the last two types of problems we're going to look at. So the more real life problem. Most tents are triangular in shape, so The front of this camping tent has dimensions shown. How much material would it take to make the front of the tent? So say you broke it, say you cut it out, whatever it is, you'd set up the same problem. Area equals 1/2 of our base, which is 3, or our height, which is 3, and our 5. So we can set this problem up. We can either say area is 1/2 of 15, or we could split them up any way we want, but it really doesn't matter. Any way we multiply with the commutative property allows us to do the path we want. So area in this case is 7 1/2 feet squared. That's how much we need to fill out that tent. All right, your turn to figure out the banner for Ari. How much paper he would need. All right, so let's work the problem. Let's see how we did. Area equals 1/2 of 12 times 6. Half of 6. I'll go ahead and do half of 12 to get the area equals 6 times 6. So the area of this shape is 36 inches squared. All right, so your ticket before you can start your homework is to write about how the previous lesson, the finding the area of a parallelogram, helped us understand how to find the area of a triangle. Okay, and remember, we talked a little bit about this at the very beginning of the lesson, how we can use the area of a parallelogram and use that to work there. So take a few moments. If it would be me, I would probably draw a diagram and then write a couple sentences to explain what I do. When you're finished with this, you can go ahead and start the homework that's in your packet, and that'll be due on Thursday.